right, your homework partial key is going to come in the form of a video, just to give a few of you maybe more of an explanation versus just kind of seeing the work. So I'm just going to go through a few of these. Again, this page 1, you just need to make sure that you had notes from the video. You can either fill it out on this page, or if you just have it on a blank sheet of paper, that's fine too. You just need to make sure that you have those 5 points and that you've written enough material in here to make sense of those things that we've gone over. This will be a good note page for you to use on your mid-quarter exam that's coming up in 2 weeks. So make sure that you have this, that it makes sense to you, and that you're ready to go. Okay, let's work through a few of these. Again, these are coming off of the notes from the videos, so just make sure that you've worked through those videos first. And I'm just going to skip around and go through a few of these. So I'm going to start with number 7. If we're looking at number 7, again, this one asks us to find the central angle or arc. This specifically is asking us to find an angle, the measure of angle EDG. So let's label that. If we start at E, we move to D, and then we end up at G. And again, remember, it's always talking about the smaller one unless it specifically states that it's talking about the larger one. So we are essentially looking for this angle right here. So notice out here, 65, 58. If this is 65 and this is 58, we just need to add those together to find the measure of EDG, which gives us 123 degrees. Okay, so make sure you're comfortable with that. Number 9, this one says solve for x. Assume that lines which appear to be diameters are actual diameters. So some of these that are written in on number 9, doesn't look like we have any diameters there. So we are just trying to find this value of x up here at the top. So in order to find x, we need to know what this measure should be. And remember, that measure is the same as the central angle that intercepts that arc or creates that arc. So we kind of look at the other pieces. Notice this piece out here is 120 degrees. This is 100 degrees. This one's 60, this one's 35. So if we're making a full circle, a full circle should add to 360 degrees. So we would take 360 degrees and we'd subtract out all of those other ones and see what's left. Okay, if we subtract all of those out, it tells us we're only left with 45. So this angle must be the 45 degrees, or in other words, this arc is 45. So we would go ahead and say, okay, well then 45 is equal to this negative 8x minus 3. And then go ahead and solve that. So we add 3 to both sides. 3 plus 45 is 48. We just continue to solve. Okay, so 48 divided by negative 8 is negative 6. Number 11, we looked at one similar to this on the notes page, so I'm actually going to look at number 10. Just again, remember that you're looking for angles that subtend arcs. So this is a quadrilateral. We know that this one and this one, right, opposite angles, these need to add to 180 degrees. And this angle W, if we're looking at this piece right here, we don't know either of these arcs out here. So not crazy helpful to look just at that angle. So we may need to use angle Y to help us out. So what I want you to notice is if you look at angle Y, this is super helpful because angle Y creates this arc out here. And this arc is 84 plus 62. So we know that this huge arc is 146 degrees. Okay, so use that huge arc. We want to find this one. Remember, if the arc is 146, then this little teeny angle in here is going to be half of that. So we take 146 and we divide that by 2 to get the angle inside of there. 146 divided by 2 is 73. So if we know this one is 73 degrees, and these two need to add to 180, then we can figure out what this other one is. So we take 180, subtract 73, and we end up with our final answer there. Okay. Jumping down, again, this one is creating the equation of a circle. So remember our equation of a circle, and I'm going to write it on the right here, is always x minus h squared plus y minus k squared is equal to r squared. So I'm going to write it in this way so that you can see the different pieces there. Okay. So down here, again, let's just look at 13 right below. My center, that's my h and my k, and here's my radius. I am just going to say x minus, but this is subtract, so we do the opposite, plus y minus, that's a positive 3, so we're good there, equals r squared. R is 6, so 6 times 6 is 36. So on this one, you should end up with this guy. Okay. The next one gives us the center and a point on the circle, so we don't know the radius. Now we talked about this one. If you know the center and you know a point on that circle out there, then this distance right here is the radius. So you need to use the distance formula to find the radius. So again, I know my h and my k, and I'm going to start building that equation. Same way we did the one up there. Oops, not y. X, and then we do minus 7, because that's the opposite of positive 7. Y plus 14, because that's the opposite of negative 14, is equal to, and we just need that radius. So down here, I'm going to find that radius using the distance formula. Again, we put that in our notes. It's always the x minus x. So let's say we take 4 and we minus 7. So 4 minus 7 plus negative 12 minus a negative. So if we minus a negative, that becomes positive. And we plug those values in there. So 4 minus 7, that's negative 3 squared. And over here, negative 12 plus 14 is 2 squared. So essentially it looks like we have 9 plus 4, which is the square root of 13. So our radius is the square root of 13. So remember, when you put it in here, you take the radius and you square it. Remember, when you square a square root, the inside just becomes the value there. Okay. Jumping over, just going backwards with a circle. Again, this one asks you to state the center and radius and then sketch the graph. So if I'm going to state the center, the first thing I'm going to do is write center, and I'm going to come up here and I'm going to look at my h and I'm going to look at my k value. So in this case, we do the opposite of negative 4, which is positive 4, the opposite of negative 3, positive 3, then I find the radius. Now remember, this is the radius squared, so if we take the square root of that, well, the square root of 1 is just 1, so our radius is actually 1. So we found that part, great. That was the first part we were asked for, then asked to sketch the graph. So we use the center first and we come over 1, 2, 3, 4. We go up 1, 2, 3. There's our center. And if it has a radius of 1, then we go 1 unit in each direction and put a little point. And then we do the very best we can to draw a circle. Okay. Number 19. This section asks us to, again, state the center and the radius of each circle, then write the equation of the circle. So again, I'm going to state the center and the radius, because remember, we need both of those to create the circle's equation. So the center looks like, for my circle, it's sitting right there. So if you look at that, that's over 1, up 3. The center is at 1, 3. Everything's positive. The radius, if I count units out to the side, it looks like it's going over 1, 2, 3 units. So my radius here is 3. Okay, then we create the equation. So we do x minus 1, because we use our center first, our h and our k here, plus y minus 3 equals radius squared. If we take 3 and we square it, then we get 9. So, oopsie, this is all that we were asked for on that one. All right, jumping down, this is the area and circumference that we talked about today, kind of the newer part. This says find the circumference. So immediately, again, if I'm finding circumference, I'm going to think about the equations I was given. Circumference is either the diameter times pi or 2 pi r if I know the radius. Okay, and we're going to leave it in exact form first and then write it in approximate form. And we're going to round our approximate answer to 2 decimal places. So let's do 21. Again, notice this is a diameter, which is 6 inches. So I'm going to use circumference is equal to diameter times pi. So circumference is equal to 6 times pi. Again, in exact form, we leave the pi there, and we just say 6 pi inches. Again, that's exact. You don't have to write exact, but just recognize it's the one we're looking for. Then if we want to approximate that, we plug that in the calculator 6 times, and we use that pi button. Again, it asks us to round to 2 decimal places, so we'll round out to 2. Okay. The last page. So on this one, again, you're asked a couple different things. This one specifically at the top is asking you for area. So again, we look at that and we say, okay, well, area is pi r squared. That's the important thing we need to understand first off, is get our formula correct. Again, it's asking for exact, approximate. In the approximate case, we're going to round to 2 decimal places. So let's look at 23. Again, we're given a diameter. Remember, area formula is pi r squared, so we need the radius. So if we take half of that, so I just want the radius, that would be like 2 inches. So area is equal to pi times 2 squared. So in exact form, we just go ahead and square that. We get 4, and we leave the pi there. Now remember, this is area, so these are squared inches. If we want to approximate that, we plug that in our calculator, and 4 times pi gives us 12.57. There's our 2 forms there. On 24 and 25, so this is asking you again, look at the instructions, find the circumference. So immediately I say, okay, well, circumference is either diameter times pi or 2 pi r. Okay. Use your calculator's value of pi, so it looks like we're approximating to the nearest tenth, so just 1 decimal place. And it looks like we're given the area. So let's look at this. Again, in order to find circumference, I need either the diameter or the radius. Well, area is pi r squared, deals with the radius. So maybe in the end I want to use 2 pi r to help me find the circumference, because they both have an r. So let's go ahead and use this. Let's put our area in here. 444.9 is equal to pi r squared. Okay, now we're solving for r. I'm going to zoom in just a little bit. So we want to get rid of that pi. Now if it's multiplying, we do the opposite of multiplication. If we multiply one side, then we have to, divide one side, we need to do it to the other side. And that gives us about 141.616. And that's equal to r squared. Now it says around to 1 decimal place, but I'm not really to the end yet, so I'm just keeping a few decimals. How do we get rid of a squared? Yes, we square root. Very good. Okay, so we square root both sides, which means that r is about, or approximately, 11.9. Okay, then we use that r to help us over here in this equation. So if we want to find the circumference, then we know that circumference is equal to 2 pi r. And we go ahead and plug that in our calculator. So 2 times pi times 11.9, 74.8 miles. Probably should have checked my answers before I made the video, but hope you're good at these. Okay, jumping down, essentially you're doing kind of the same thing on these. The next one says find the area of each. So remember, area is pi r squared. Now this one just asks you to approximate, so you just need to approximate on each of these. I'm going to jump down and look at 29. So on 29, you're given the circumference. So remember, I want to find the area in the end, and that's pi r squared. So I need this r, or the radius. So circumference is 2 pi r, so let's use that guy to help us find r first. So we do the circumference of 50.3 is equal to 2 pi r. Now we did one like this in the notes. If this is multiplying here, we need to get rid of that 2 pi. Divide it over here, and we put it in parentheses to make sure our calculator divides that correctly. Once you divide that, then you can find that r value, which is about 8. I think there's a decimal there, but 0.000 or something like that. Then you can find your area. So we go ahead and use this to find the area. Put 8 right on in there, and you can go ahead and calculate that. And remember, this is area, so we'll end up with square feet. Okay, there's some good examples of how to kind of find that on these last ones. Again, you're asked to find the diameter, so you need to look at what you're given. Remember, area is pi r squared, so it'll help you find the radius. And then you'll need to double that to help you find the diameter. So on those last ones, go ahead and find the radius first, like we did on previous ones. And then double that to find the diameter. Great job!